Hello everyone, this is Ms. Shaw. I'm doing a recorded lesson so that you can complete your asynchronous work for Monday 9/28. So what I'm going to do right now is share my screen. That way we can all see the card I'm referring to. Boom, here we go. So I'm going to do a couple example problems from the Google Doc in the Chemistry 9/25 classwork assignment. You have a card for today. The only way that you got this video is if you clicked on that card, but I want to be clear that the work that we're completing is from the Chemistry 9/25 card. I'm not giving you the Google Doc twice, I'm only giving it to you once. So what I'm going to do is scroll down and open up this Google Doc. It'll take a second for everything to load. If you are not here on Friday and you do not have the notes for the heating curve and cooling curve, please pause this video and send me an email right now because this is going to be more or less impossible to do without those notes. Alrighty, here's our heating curve. Remember the plateaus. That's where we go through a phase change. Here we go through a phase change. Here we go through a phase change. I mentioned this briefly, but I'll say it again. The reason we plateau, the reason the temperature does not change is because while a substance is going through a phase change, the particles don't go any faster. Okay? So here we have a solid, particles are going faster and faster and faster and faster. And then once they hit the magic temperature where they start to change their phase, they don't actually move faster. What's happening is that we're karate chopping all the connections between the particles. That's where the energy is going. So we don't have a change in temperature because we don't have a change in speed. All the energy is going to breaking the connections between the atoms and molecules. Okay, boom, boom. Same thing in the cooling curve, except opposite. The reason we don't have a temperature change here is because all the energy is going into rebuilding those connections between the atoms and molecules. Okay, I'm going to scroll down and let's take a look at part 2. So in part 2, your first job is to determine the freezing point / melting point. Remember, it's the same temperature, and boiling / condensation point. Again, same temperature for boiling, condensation, same temperature for freezing and melting. You're then going to graph these processes. And like I said, you have to do it on a separate piece of paper. Doing it on this is just too much of a pain in the butt. I'm going to give us 2 examples today to show you how to do this. I'm going to do number 1 and I'm going to do number 6. I'm doing number 1 because it's a heating curve, and I'm doing number 6 because it's a cooling curve. Let's start with number 1. The first thing I need to do is figure out if it's heating or cooling, right? And the way that I do that is by reading this problem. So here it says water is going from 24 degrees Celsius to 123 degrees Celsius. From 24 to 123, that water is getting hotter. This is a heating curve. What I'm going to do right now is set up my whiteboard so that I can draw this for you. And I've got my stylus. Let's see how this looks. So, okay, I'm going to get things set up really fast. Hold on just a moment. There we go. I'm going to write at the top what I'm doing. So this is water. From 24 degrees Celsius to 123. Let me just check real fast, double check the temperatures. Correct, 24 to 123. And I have to go back to, 24 to 123. So let me start by outlining my axes. If we remember my x-axis, because it's a heating curve, this is going to be heat absorbed. You could also say heat added, heat going in, any of those work, right? But the idea is that the heat is going into our system. And then my y-axis is temperature. One of the first things I'm going to do on my y-axis is label my melting point and my boiling point. Anytime I have water, it's going to be the same melting point and boiling point. If I have a different substance, those numbers will be different, right? I gave the example of iron in class. Iron does not melt at 0 degrees Celsius. It has to be way hotter, right? This is specific for water. All your examples today are for water, but in the future, I'm going to make you tomorrow, in the future, I'm going to make you do a couple examples that don't have water. Alrighty, there are two different ways of drawing this curve. One way, which is the easier way in my mind, is to draw the entire curve. So let me outline it. Here we go. You draw the entire curve, so starting here, and then you hit the plateau at 0 degrees, and then you show the heat going up until you hit 100, then it plateaus again, and then it goes up. Right? So you draw the entire curve, and then you look at your starting and final temperature. Right? So my starting temperature is 24, and what I'm going to do is change my color. That way I can annotate here. So starting temperature is 24 degrees. So I'm going to look on this y-axis for where 24 would be. So 24 would be about a fourth of the way through. So it's about halfway. It's about there. Then I go over onto my curve and I put a starting dot. This is where 24 degrees is. So for this scenario, anything below 24 degrees, I shouldn't have in my graph because this is where my water is starting. It's starting at 24. So what I'm going to actually do is I'm going to erase. Whoops, that was not the eraser I wanted. Let's undo all of that. Let me see if there's a better eraser. Huh. Click there. Still figuring out the system. I have another idea. This will work just as well. I'm going to erase. Oops. Thank you for your patience with me as I figure this out. Okay. I'm going to erase anything below 24. And the way that I erased it was just by using a white line, but that works. Anything below 24, I'm erasing. Okay? So I'm starting here, about a fourth of the way through my liquid. And then my system ends at 123. Okay? So at 123, that's above 100. This is 100, it's above 100. So I'm going to go up a little bit until I end about there. Right? So this is about 123. Again, it doesn't have to be perfectly exact. And so anything above 123 is not part of my description. And so I'm not going to include it because it's not part of the description. And this is just the portion of the graph that I'm asking you to draw. The water starting at 24 and then going to 123. So here I'm starting at 24. I'll even label it 24 degrees Celsius. And I'm ending at 123 degrees Celsius. And this here should be a little bit sharper. Oh no, that's really messy. I'll just leave it. But this should be, see how it's kind of curving? That's a messy drawing. It should be curved. There we go. Okay. So this is one way to draw it. You do the entire curve and then you erase the before and the after. I'm going to show you a different way of drawing that doesn't involve erasing. It just involves drawing from the beginning to the end. Okay. Still the same problem. I'm going to write that down. Water from 24 to 123 degrees Celsius. So I'm doing the same problem. I'm just showing you a second way of answering the question. So I'll just set up my axes again. Okay. So my x-axis is heat absorbed. My y-axis is temperature. I'm going to do the same thing where I label my melting point and boiling point. It's water, so I know that my melting point is 0, and I know that my boiling point is 100. Cool. And now, instead of drawing the whole thing, I'm going to look at where I start, and that's where I'm going to start drawing. So 24, I am about a fourth of the way between 0 and 100. This is about halfway, about a fourth of the way through. So 24 degrees, I'm going to start there. 24 degrees Celsius. So 24 degrees, my water is liquid. And I know that because it's above the freezing point and it's below the boiling point. So between freezing and boiling, my water is liquid. It doesn't hit any of the plateaus quite yet, so it's just going to increase in temperature in a relatively straight line until it gets to 100. And I know that I go past 100 because I'm ending at 123, right? So in order to get past 100, I have to go through this phase change of boiling. So then we see this plateau as I go through that phase change. Once it's all boiled and it's all gas, then my system gets hotter and hotter and hotter again until I hit my final temperature of 123 degrees Celsius. Okay. So this is a second way of drawing it, is you just start right on the graph. You have to figure out where am I in a solid, liquid, gas, what's happening, what phases do I go through, and then where am I ending. This one's a little bit more advanced, but both ways work. All right, let me clear this. What I'm going to do now is I'm going to go back to our problem. And I'm just going to review question 6 with you because right now I want to go over question 6. So question 6, I'm starting with water at 0 degrees, going to negative 50 degrees. Now, there's a piece of information that I need to know, and this is my bad that I didn't give it to you. You'll notice here, I say water is vapor, liquid water. I didn't tell you here if it's liquid or solid. So please add in for number 6 that this is liquid. Oops. Liquid water, starting at 0 and then going to negative 50. And it's going to be a cooling curve because I am decreasing temperature. All right, let me sit on my whiteboard. So this is question 6, liquid water. From 0 degrees Celsius to negative 50 degrees Celsius. Okay. And if I take a look at this, I'm starting at 0, I'm ending at negative 50. This is getting colder, so I know I'm going to be drawing a cooling curve. Let me set my axes. When something is getting colder, a cooling curve, this is heat being released. So any phrasing that talks about heat being released works. Heat going away, heat being removed, heat being released, all the things. And then temperature is my y-axis. You'll notice that temperature is always my y-axis for these curves. Temperature. And then I'm going to label my melting point, 0 degrees Celsius, and my boiling point, 100 degrees Celsius. I'm doing it sideways because I'm having sideways. Okay, cool. So I'm going to do this 2 ways, just like I did the heating curve, 2 ways to show you 2 different examples. So one way, the easier way in my mind, is to start by drawing the entire cooling curve and then erasing the parts we don't want. So my cooling curves always start here at high temperature. We've got my gas that is cooling off, and then it hits 100 degrees, goes through condensation, and then I've got my liquid that's cooling off, cooling, then it hits 0 degrees, goes through freezing, so we get another plateau, right? And then it becomes a solid, and the solid gets colder and colder and colder. And this will go down as low as it goes. Alrighty, let's check this out. Liquid water starting at 0 degrees. So here's 0 degrees, right? But you can see that it's a plateau, right? So I can be at multiple points along this line. So 0 degrees, I could be anywhere here, which is why I need to know if I'm liquid or solid, right? It says I'm starting as a liquid. The liquid is right here, right? Because this is my liquid phase. So at liquid at 0 degrees is this beginning point of this graph right there, right? It's not in the middle, because in the middle it's halfway through. It's half liquid, half solid, right? So if it's all liquid water, it has to be right here, right as it hits 0. And then I go to negative 50. So 0, anything below 0 is negative. So negative 50 would be about here. Would be about there, partway through my solid. Right? So anything negative 50, oops. Anything below negative 50 is definitely solid. So now what I'm going to do is I'm going to erase the parts of the graph that are above and below my 2 dots. Erase, erase, erase. And so for this scenario, the only part of the graph I want is this shape right here. It looks a bit funky, but that's the way it's meant to look, right? It's not the complete cooling curve, it's only part of it. Liquid water, cooling off, freezing, and then cooling off to negative 50. And then here I can put in my temperature. 0 degrees Celsius, negative 50 degrees Celsius. So that's the easier way to do these, right? But again, it requires an eraser. So if you want to go the quick way, let's set it up so we do it quickly. This is number 6, water from 0 degrees Celsius to negative 50 Celsius. I'm going to draw my axis again. I guess I should leave my axis, but whatever, it's the last example. On the y-axis, I'm going to put temperature. I'm going to label 0 degrees Celsius, 100 degrees Celsius. My x-axis is heat release. Okay. Now, because I know cooling curves really well, I don't have to draw the whole thing, right? I can start at one point and end at the other point. And so the liquid, ooh, I forgot to put that this is liquid. Liquid water from 0 to negative 50. So liquid water starting at 0, so I'm going to be starting at 0. I know that liquid water has to freeze first. So I know I'm going to be starting before the plateau. I'm going to have to go through the plateau before I can get to the point where it's all solid, and then it can cool off to negative 50. So I'm starting at 0, plateau, all solid, and now my solid can cool off until it hits negative 50. Okay. So that is 2 examples. What I would like you to do today, so today, Monday, you're only supposed to have 20 minutes of work, right? Well, you've already done 2 of the problems. Great. I'd like you to do 1 more. Okay? Please try 1 more problem on your own. And that'll be a little bit less than 20 minutes, but it'll be enough for today. Tomorrow, you're going to finish the rest of the problems. Okay? So tomorrow, if you get stuck, please come back to this video so that you have the examples again. Tomorrow, you're going to work on the rest of part 2, and I'll be assigning a couple of challenge questions tomorrow that are not water. So the melting point and the boiling point are going to be different temperatures, but I want you to try those tomorrow. Alrighty, I'll see you on Thursday.